Everything went well. All right, it's the beginning of class, and I didn't totally screw up the previous recording. Let's go ahead and get started. The first thing that thou shalt know is compass directions. So let's review for a second. If that way is north, okay. I got 95% of you, but I need 100% of you because it will be very important and you will miss points if you don't know it. Okay? So in terms of compass directions, thou shalt be able to identify if I am facing north, behind me is south. Never eat soggy waffles, sure. Or shredded wheat, depending on your preferences, dietary preferences. If I am, what am I doing? If I am facing south, my right hand would stick out and point west, whatever. You need to be able to do that. Behind me, if I'm facing east and west. Hopefully that is in these ones. Okay, second quick quiz B is, what are the units of force? Don't tell each other. Chop, chop, quick like a bunny. What are the units of force? If you are very directionally challenged, by the way, draw the compass needle. Draw the compass needle and imagine yourself facing this way, that way, or the other way. Every darn problem. You all remember. It was beaten into your heads properly. Okay, the equation for force is F equals ma, or that's Newton's second law, but the units for force, meters, kilograms, seconds, newtons, pounds, joules, mamas, yos, meters per second, blah, blah, blah. How do we measure force? And the correct answer, as we have also about 95% of you remembering, is newtons. After my pal Isaac. Force is measured in newtons. Do not get newtons confused with north. Okay, so let's give a briefest of brief overviews of magnetic fields and correct a typo. A magnetic field whose symbol is B and whose unit is the Tesla, T, capital T. Here's what a magnetic field tells you. Which way would a compass needle placed in that field, which way would it think north is? Every needle, every magnet has a north side and a south side. You put a compass needle on a pivot, you put a compass needle on a cork in water, whatever, it will align pointing in the direction of the magnetic field. That's how we define the positive direction for magnetic field. It is the northward direction. It is what a compass thinks is north. Now, just like electricity, we're very heterosexist in this, or heteronormative in here. Opposites attract. Like poles repel. North attracts south, south attracts north. What's in Greenland? Or the Arctic Circle, I don't know. I think it's north. What's up north? Opposites attract. The north side of the compass points where? Canada or Antarctica? Which way is the North Pole? Yeah, Canada's in the North Pole, somewhere in Canada, Greenlandish. And the North Pole of a compass is attracted to it, yeah. So what's the magnetic polarity of the North Pole? If opposites attract, North Pole is south, magnetic. Okay. We call them negative in magnetism sound. Okay, so again, I want to make this point here. If I talk about the sign, the direction of the magnetic field, which way does the magnetic field point? Anywhere. Anywhere with 2 plus on it. Points north to Canada. The magnetic field points north. The magnetic field, you can determine the direction that it points, that it thinks the direction is positive is north, and which way would the north side of the compass point? But north sides of compasses are attracted to what size of bar magnet? South. I mean, Greenland might be the North geographic pole, but it is a physics south pole. Know that. Know that. The polarity of the planet as a whole is the opposite of what we say geographically. Secondly, I use 50 as my rounding for in-class approximations, but for your homework, you actually do need 268. 52 microtesla. You guys know what a micro is? Remember, micro is 10 to the minus 6. Good, okay. So you will need this. 52 times 10 to the minus 6 Teslas. Please note, Earth is actually quite weak. I personally have made a magnet 100,000 times the strong, an electromagnet 100,000 times the strong in a lab. It is no big deal. And I'm not the biggest magnetic field in the world. So you can easily overpower the Earth's magnetic field. By the way, you are welcome to ask your instructor. I will do my darndest to remember to tell Mr. Bailey, who is new this semester, where this is, but there are compasses and bar magnets in the lab room. I would encourage you, play around with a compass and a bar magnet. If you haven't done it since you were 5, it may be useful to get a feeling for these things. Yeah. Okay. Oh, what did I just say? What's C? I mean, this is C. What did I just say? Put it in the Google form. Which way does the compass point? Lots of people are telling me northeast, southwest. I'm not saying in the Earth's magnetic field, any magnetic field. You make a magnetic field somewhere, which way does the compass point relative to that? Not the Earth. Could be the Earth, but in general. There's no electricity in a compass. There's a magnetic poles. Electricity and magnetism are related. They are not the same thing. It's neutral. It is magnetically north. It is like a positive charge. Define that as the positive direction. And do be aware that it is not an electrical charge. Okay, what I was fishing for is in the direction of the field. We define the direction of a field by which way a compass would point, so a compass would point in the direction of the field. If I had included the word Earth's magnetic field, what would the answer be? North. Why is that Earth? It's not. I didn't say Earth's magnetic field, so you should answer in general. The most general thing you could say is a compass in any magnetic field would line up pointing in the direction of that field. So far, so good? Yes, no, maybe so? Yeah, question. Oh, yes, very much so. Oh, very much so. Oh, wait, I want to make another point here. I forgot to emphasize this. North and south are not plus and minus electrical charges. There is a connection between electricity and magnetism, but it's not that. There is no electrical charge on the north pole of a magnet. There is no electrical charge on the south pole of a magnet. I'll go into the details of how a magnet, either an electromagnet or a bar magnet, make magnetic fields later, possibly. But for now, you just need to know that electricity and magnetism, magnetic poles and electrical charges are completely separate things. Okay, there we go. Yeah, good. Okay, now, you might think that we're going to talk about the force between two bar magnets, or the force of a magnetic calendar on a fridge. Unfortunately, it turns out that those equations for those real world, common experience, everyday 5-year-old can see this thing are horrifically complicated. What you want to be calculating with is talking about individual charges moving in an external field. So what I'm going to focus on for this week is I'm going to give you a field direction. I'm going to assume that we've got a constant, steady magnetic field. That could be the Earth's field, or it could be something I create in the lab. Nice, steady magnetic field points in some direction. I give you its strength. I give you its direction. I want you to figure stuff out about which way a moving charge would feel push. Moving charges, moving electrical charges, feel magnetic forces. Permanent magnets also feel magnetic forces, but moving charges are the thing that we're going to focus on. That follows a simple equation. Well, you decide for yourself whether it's simple within the next 30 minutes. So the entirety of this chapter, this week, is understanding the effect of an external magnetic field created by God knows what, doesn't matter. I'll tell you, will be given on a moving charge. Here we go. I've got a charge with magnitude Q moving in a magnetic field at CG. If it is moving in the direction of the field, no force. If it is moving perpendicular at right angles to the field length, B and B are at right angles, then it will experience the force of charge times velocity, power times speed times magnetic field. QBD. Okay, what's all about that? Two things. One, you gotta remember they're at right angles. They have to be right angles. For my MCAT students, you can put a note for yourself. If they're not at right angles and they're not directly in line, the general case, throw a sine theta. So QBD sine theta, the general case. I'm only going to give you right angles, perpendicular, or parallel. MCAT may ask you to do 30-degree angle, and so on and so on. Okay. So what's so hard, first off, is remembering if they're going in the same direction, velocity and field go in the same direction, nada. If they're going at right angles to each other, the field is crossing. If the velocity of the particles crossing the field lines, that's when you get a force. The direction of the force vector is the hard one. You might think that a field pushes in the direction of its direction. You might think that a particle which feels a northward field would experience a northward force. Ain't the case. That is not true. A particle moving eastward does not get pushed northward by the Earth's magnetic field. Instead, you need to learn something called the right-hand rule. But first, notation. North, south, east, west, up, down. That's one coordinate system, yeah? If I talk about geographic coordinates, you okay with north, south, east, west, up, down? There's a second coordinate system that you need to know about. Nope. I suck at perspective drawings. Not going to do that. Doesn't go circle around the symbol. I think that leads to confusion in lecture, in my notes. I will always put the circle. FYI, you're going to see in the homework problems. Sorry, I can't change them. There's not going to be a circle around. The magnetic field direction will just be X's or dots. I think that's good to me. Sorry. Textbook, same way. Okay. I will always represent the direction of a vector pointing out of the page as a dot in a circle. Textbook will just put a dot. I will always represent a magnetic field which pokes into the board or piece of paper or whiteboard or whatever as a cross, an X in a circle. Here's how to remember them. I'm an archer. Ew, what do you see sticking out of the board? What's at the back of an arrow? The fletching, yeah, okay, someone knows that one. Okay. The fletching, the feathers, right? What pattern do the feathers make? So if the arrow is sticking, pointing into the page, what do you see? You see the fletching, the X, the cross, the arrow, the tail feathers. I'm going to stand behind the board, use a really little bow, pew, poke out at you. What do you see just before you lose an eyeball? The arrowhead. There's the arrowhead sticking out at you just before you lose an eye. Okay. So if it is going into the paper or whiteboard or projection screen or whatever, away from you into whatever you're looking at, that's the inward direction. And then if you see it poking out at you, about to die, that's called the outward direction. Towards you is the out of the paper. Good? Now we're going to do a billion examples, or I'm going to introduce the law. I'm going to lay down the law. We're going to do a billion examples because experience shows it takes a billion examples. Let's go. Here's the right-hand rule. In general, this is not just true for velocity, field, and force. In general, we can always do what is called a cross product here as follows. First finger, thumb, first finger, palm into thumb. Point your first finger in the direction of the first vector. Point your palm in the direction of the second vector. Your thumb sticking out makes the third vector, makes the result. What? You got to do this. Hold up your right hand. Okay, I came up with a silly and profane, so it's hilarious, way of remembering where your fingers go. Okay. So what I suggest is get a present from your uncle. Hey, give me a present. Oh, the present sucks. Flip them off. Leave your first and second fingers in this orientation. You can move your arm any which way. You can move your arm however you want, but your fingers don't move. Okay? Receive your present and flip them off. Yeah? If you want to, your ring and pinky can go anywhere you want, as long as your middle finger is sticking straight out of your palm. Notice my palm direction, straight away in the palm direction. First finger has to be stiff out, fully extended. No, can't move anymore unless you're double jointed, in which case you sorry to gut, but in which case don't bend it backward. Common goof. We are not winners. Wait, what is this? Other than very rude and prince? We're not peace. We are not hippies. No peace in physics. No peace for you. If you find yourself doing this, you've done it wrong. Look, get the present. Get the present. Are you flipping anyone off? No. Get the present. Flip them off. That's where your middle finger goes. Note, there is a right angle between your middle finger and your index finger. If there's not a right angle, you're doing it wrong. How I'm going to guide you to do this is as follows. You're going to be flipping people off left, right, and center. Stick your fingers into this orientation. Oh, and your thumb goes straight out. I was walking around doing this. Hey, thumb goes straight out. One more thing, one more screw up, one more common goof is people curl their middle finger. Curl middle finger points in the opposite direction my first finger. That's not a 90-degree angle. 90-degree angle. And my thumb, look, my thumb, I'm not doing it right now. My thumb is parallel to my middle finger. Full extension. Stretch that first and thumb out all the way. Point the finger, point as pointedly as you can point. Middle finger, right angle to that. Thumb fully out. Also, put your left hand in your pocket. Don't use your left hand. Unless you're lefty, in which case you can continue to write and do the exam while calculating. Okay. The order matters. Always write QD, cross B, QB first, B second, because the order of the fingers makes a difference. Let's do this. Let's do this. Let's use this page as an example. This page right now is demonstrating that right cross out is up. Why? First finger. First finger is the first vector. Right is the first vector. Left, sorry. Left, left. Everyone point left. Everyone point in the direction that the hand is pointing. And everybody's first finger. You're pointing out too. Not this. It's this. Everybody's get the present, flip them off, and then which way is out? Which way is out of the plane of the paper is back of the classroom. Stick that thumb up. Stick that thumb way up. Ready? Yeah. Thumb will point up. I mean, as it's showing. So this is showing that first finger left, cross second finger out, the resultant is up. This is the best diagram I could download. It is not always true that force is B cross B. It is not always true that force is first finger cross second finger. If Q is negative, flip the result. This demonstrates a rightward moving particle in an outward magnetic field feels an upward force if that particle is positively charged. If the particle is negative, an electron, for instance, would feel a force in the opposite direction. An electron would be pushed down. Now it's time for a billion examples. What are we on? Question C, question D, D. Work with your neighbor. If your neighbor and you can't together figure it out and be sure, call me over. Okay. Oh, what if two are parallel? Stick your fingers in this orientation. Point this finger towards your right. Point this finger towards your right. Wait, no, keep the first finger towards your right. No, but now the second finger also keep it further right. What's the cross product of right cross right? 0. You cannot orient this triad of fingers so that two of them point in the same direction. Yeah, does that make sense? This means if you think about this, this shows you that a particle moving in the direction of a field line experiences no force. Right? If B is this way and B is also that way, no worky. There is no direction that you can orient this in so the two fingers point in the parallel direction. Yeah, anyway. Oh, I already did that one. All right, 8 examples. Should be enough to. Oh, sorry. Last note before we start. Use your arms, twist your arms around, but please don't smack your classmate sitting to your right. Watch out for that. Okay, ready, set, go. Remember the orientation and practice. I'm going to give hints. Yeah, do it together. Do it together. Do it together. I'm going to give the first couple of answers in a couple of minutes. I'm going to pause the recording. Okay, hold on a second. Hold on a second. I've seen progress. I've seen people doing it right. But it's also hard at first. First thing, first challenge, first task. Always form your fingers. Form 9 fingers. The only mnemonic to remember it is get your present, flip them off, stick your thumb in. And you can do whatever you want with your fingers. Okay. I got my triad. I can move my arm whichever way. I can and will move my arm whichever way does not poke my classmates' eyes out. And I'm going to orient first finger, second finger, and get third finger as the result. So I orient first finger's first finger. If I'm getting D up is the first finger, so pointer up. Now, a very common thing is for people to then point their first finger left. Once your first finger is up, it stays up. You can rotate this way, but you cannot rotate the first finger right. Rotate around the first finger action. Okay, up, cross, left. I orient my middle finger pointing to my left. Your first finger up. Again, your index finger should be pointing to the sky. Your middle finger should be pointing to your left. Hope you know you're from your left and your right. My wife doesn't. Which way is your thumb pointing? Out. Out of the page. If you're having trouble with in, out, just remember towards you is out of the page. Away from you is into the page. If I shoot an arrow away from myself, I'm pointing into whatever I'm looking at. When I say out of, talk about coming towards me, into, away from me, imagining that I'm reading a book. So the correct answer for D is out. Second calculation. Form your triad. Form your coordinates of your fingers. First finger left. Second finger up. Ooh, that's the root direction. Third finger which way? In. Away from you is in. East. Again. Form your triad. Make sure you're using your right hand. First finger, your index finger points to your left. Your index finger, rotate that so your palm side, your middle finger side is up. You should see your thumb pointing away from you. That is to say, into the page. In. Note. Up, cross, left, out. Left, cross, up, in. They are opposite. If you get the order of the vectors wrong, you will always get the wrong answer. Don't do that. Make sure if we talk about V cross B, V is the first, B is the second. Later we'll come up with other things. This way is negative up. There. Or what I would do, so what I'm going to do next is actually I'm going to do up cross left. And flip it. Instead of turning up and just negative up and down, what I always do is I'm going to calculate the cross product. The two things cross, up and left, up cross up, and then negative that. Well, we're going to do up cross up in some direction. The opposite of that direction. Okay, let me say that for everyone. Wait, you had a question first. Oh, yes, sorry about that. I'm doing it for myself. Okay, third one, negative up cross left. As I was just saying, to K Money, I strongly encourage you to prefer names. I tell people they prefer names when I wrote. Like K Money's hard to forget. I encourage you to do this in two parts. Don't turn up, negative up into down. I encourage you to do up cross left and then flip that with the negative sign. Yeah. Okay, let's do it. Let's do up cross left. Up. Face the same direction you are. Left. Middle finger's left. Which way is up cross left? Is up cross left is out. Negative up cross left is in. What happens if we did negative up is down, down cross left? First finger down. Second finger left. Third finger is in. Oh, you can do it that way. You could turn negative up cross left instead of negative up cross left, but you'll get in is the same answer either way. Math is inherently consistent, but I suggest that you do the cross product first, then throw a plus or minus sign on. Questions before I demonstrate G? In cross up. Which way is in? Point in. Everyone point in. Nope. That is out of the projection. Into the screen. Everyone should be pointing out the screen. I mean, I guess people facing that way can point away. Sure. Okay, great. Everyone in this section should all be pointing at me. I can see it doing it. Okay, in, cross up. Ooh, that's the rude one. The fun one. You're immature like me. Which way does your thumb go? Which way does your thumb go? Point. In, cross up is right. That's right. Are you sure? You're right. Pro tip number 5,000. Note that each direction, the resultant is always at right angles to the things that go into it, to the ingredients to the recipe. So if I've got up and left, the answer can never be down or right, or up or left. The resultant to up and left can never be up or down or left or right. It has to be in or out. It has to be a right angle. If I've got east and west, what is east cross west? Point your first finger east and then at right angle to that, point second finger west. You can't! Correct answer for 8, you're 0. I'm fine. There's no direction. 0. Cross solid down. Okay, let's do one that isn't 0. North and down. Answer cannot be north or south. The answer cannot be up or down. Has to be the remaining direction east west. Now take another minute. I already gave away I. Do H, J, and K. And I'm a pause again. Okay, let's do the next 4. Why? 4 that I didn't already do. How I encourage you to do, if you're directly challenged, draw the compass rose, north, east, south, west, never east, center, east. And then what I strongly encourage you to do is imagine, or actually turn it physically face. Imagine that some direction is north and physically face the next direction. So for instance, north cross down. I'm imagining, just for the sake of it, that front of the classroom is north. Great. I'm facing north. First finger north. Northward ho, young man. Second finger down, point. Where does my thumb go? Left. I'm specifying north as one of the coordinates. I'm talking about northeast, southwest. What is leftward compared to north? California, girls. California, girls, which is west coast. Also to the men in the guys. Okay, north cross down is west. East cross west. I already said, what's that? 0. Direction indeterminate. East cross down. All right, if this is north, which way is east? North. Texas is that way. North, what? Towards the flag in the room. Oh, it must be the Texas side. That's where the flag is. Okay, east cross which? Cross down. Okay, which direction my thumb going relative to the compass? What did I say towards the border? North. East cross down is north. Last one. Question first.
When you get a compass direction, should we answer it in a compass direction?
Yes, if there's a compass direction, you can answer in terms of it. If I say left, right, you can answer in terms of that. The left, right, in, out. Answer in terms of that. No matter. All right, in, cross, left. Everyone show me into the blank page. I feel so very attacked. Oh, into the page. Point at me. I am into the page. I am the page. Not into you. Not into you. It's not about you. It's about the paper. Now point into the page, into the page. Cross left. Rotate your finger so that your palm, your middle finger is pointing to the left. Which direction does your thumb go? Up. Good. First result for 8 cross left is up. How do you feel about this? Easy peasy lemon squeezy? Hard, difficult, lemon difficult? Yeah. Let's do it. If this is north, east, down, east, down.
Yeah, so I entered some of them.
Question. Find you first. Oh, that was always about direction, but you were just showing north, south, west. Don't have to break your arm while you're being assignment. I mean, get a good grade on the test, but don't break yourself. Yeah, it's okay. Okay, a second way to do this, if you really hate rotating your arm, is that if your first finger is the way you're facing and your second finger is your left ear hole, then your head points up in the direction of the resultant. I would love it if you did it this way. Then when I give you a test, I'm going to see lots of people doing this and this and so on. That would be hilarious. Yeah, think about it. Think about it. If your first finger, if you're facing your first finger and your left ear hole is your second finger, is it this the resultant direction? You can make up as silly as example as you want. I am uniformly always going to do this. Oh, by the way, congratulations. You have now been inducted into the electromagnetic gang, the physics gang. Here is our symbol. Right hand. Woo! Be careful about doing that around town. The physics gang is in fierce competition for territory with the math gang. They'll beat you up with their algebra batons. I don't know. Okay, shall we do numerical example and numerical and calculational example? Too bad, we're doing it another way. Tough luck. I'm gonna make up some directions. Half a second. Pencil's bad. No, pencil's good, but I'm bad. There you go. I can give you directions too. So I'm doing a lab experiment. I generate a half Tesla magnetic field, which is pointing vertically upward. And then I shoot a proton moving really fast northward. Hey, what's the charge on a single proton? 1.6 times 10 to the 1.6 times 10 to the negative 19 is a single proton's charge. What's the single electron's charge? Electron's just a negative proton. Well, I could put negative 1.6 10 to the negative 1. Okay, so for this, Q proton, 1.6 10 to the negative 19 coulombs. And let's break this into 2 parts. What letter are we up to? L. M. Now, how do you put and which way? Oh, you specify in terms of like northward and upward. Which your answer be in terms of? Eastward and westward, eastward or westward. Compass, right? Yeah. Okay, chop, quick, think of bunny. Work with your neighbor.
They're giving more, nothing more.
Correct.
They're giving. In.
Pick the third act. No, if you pick the third act, you have a 50-50 shot of getting it right if you know nothing else other than it can be parallel to the initial. Coulomb. SI units, coulombs. The Q of a proton, the charge of a proton is 1.6 blah 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 coulombs. That is the number of charges in 1 coulomb. This is the number of coulombs in 1 charge. Reciprocal. What's the difference between the number of eggs in a dozen and the amount of a dozen? How many dozens there are in 1 egg? The reciprocals. 12 versus 112. Pardon. That's the relationship between 1.6 plus blah 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 and 6.25. What?
1.6 in the next section.
V and B. Okay.
Point five. So the proton and it's discharge, magnetic field at the hospital.
Express in it's you like me.
Gives you the
That's QB. That's QB. You times each one.
Let's see what.
Nope. Oh, yes, sorry. Yes, yes. So where's your V? You must have been.
1.0.
Sorry, yes, the 1.0. Oh, for God's sake, I can't read. Okay. Yes.
Q being.
Q is start. Q is start. Q is always Q loads. V is in a second. Yeah. That's perfect. All right. Let us be fruitful and multiply. What? Look at what? What? Hey, ask me a question. Where are you gonna start? But they're not going along. They're north and up. Northward is towards Canada, upward is towards outer space.
So if we were reading this question from the correction specified.
You couldn't do it. You couldn't do it. The correct answer would be answer indeterminate without verification. No, you're more likely to put something across. It's parallel direction. Which direction, what is the direction of the force on something moving northward? That's fine. Northward force, northward magnetic field, the Earth's magnetic field.
Yeah, just.
Yeah.
On the homework, we had 2.5 times 10 to whatever, proton, we multiply that times 1.6 times the charge.
Let's say it again, 6.25 10 to the 18th, what?
Something, 2 point something, times the charge proton, the charge.
This is one. The charge of 1 coulomb, where is 1 coulomb? If you multiply the charge per proton, per coulomb, you will get 1. Right. That's what it is. 6.25 10 to the 18th. And 1.60 something on the 19th. It's 1.
1.6.
These are reciprocals of each other. So it's per coulomb per. Other questions? Give me more questions. I hunger for them. I thirst for them. Something more associate teaching professor question, assistant teaching professor question? Yeah, Dave.
If we changed it from a proton to an electron, does that change?
You tell me.
Yes, so it'd be negative.
Exactly. Q is negative. Okay, final words. We're almost out of here. Final words. Last semester we did 4 modules: kinematics, dynamics, circular, energy. By far, y'all's favorite, I'm sure, was circular motion with its 15 terms. You got to dust off a little of it, a little of that. We're not going to be doing a ton yet. We'll do more of the very last module this semester. We're not going to be doing a ton, but you do need to remember what centripetal acceleration is for next time. You do need to remember the idea of centripetal acceleration. Let's just talk about the concept for half a second. The 2 shakes of a lamb's tail, as my father would say. And here's the idea. If I am going up and accelerating up, I'm in an elevator. It is moving upward and accelerating upward. What happens? To describe what happens if I accelerate in the same direction as I move. You can say, if I accelerate in the same direction that I move.
Speeding up.
I speed up! Move. If your velocity and your acceleration are parallel, you speed up. What if your velocity and your acceleration are anti-parallel? I'm going down and I'm accelerating up. Slow down. Acceleration anti-parallel to velocity slows you down. The third kind of acceleration besides parallel, third kind of direction besides parallel and anti-parallel, perpendicular. What happens if I'm going along the y'all's right and I experience a shove towards you? What happens? Did I speed up? Did I slow down? I turn. Remember, to a physicist, all of the main controls of a car, the big 3 of a car, are accelerators. The gas pedal, yep, that accelerates me. The brake, oh yeah, that accelerates me, opposite direction. And the steering wheel, that accelerates me. It turns, it changes my velocity vector by turning which way. So the bigly idea behind centripetal acceleration is that circular motion is also accelerated. And then there's that fancy pants formula that we'll review on Wednesday. And then there's that connection with the circumference equals 2 pi times the radius. There are a couple things, but I strongly suggest that thou shalt review a little bit about the meaning and nature of centripetal acceleration. Okay, Merry Christmas. You get to go early.
Doing this last one in.